Today's video is about the Big Bang Theory, not the show, the actual theory. Okay.
Actual event.
Just so no one's confusing things, this is our astronomy unit. Okay. Astronomy is the study of space.
Space.
We're also going to talk a little bit about cosmology. There's actually a show on called Cosmos right now.
Right. Very good show.
It's all about this. And cosmology is a study of the origins and the future of the universe.
So
And
everything.
Yep.
Everything.
Not to be confused with cosmetology, which is
Right. Well, yeah.
hair and makeup.
Yeah.
Sorry.
So now the Big Bang Theory that we're about to talk about is the most widely accepted theory that explains how the universe actually started. Now, once again, theory does not mean it's just some guy
Not an idea.
went like, oh yeah, that might be how it
It's
happened.
been tested and measured
Yeah.
and pushed on, and it still holds up.
Yep. So we're gonna show some of the evidence for that.
Yeah, let's
But just so you know, astrology, where we talk about like, are you a Gemini or I'm a Gemini? But what are you?
I'm an Aries.
Well, it doesn't matter because it's not
It
science.
doesn't.
It matters.
Astrology,
I like being a
it has to do. I mean, it got established by the
Right.
sun being within a certain constellation, so it has its roots sort of in science. But astrology itself is not science.
No.
You can all those
So
things. that
do
they
not
write
ask
about
me
are
about
easy.
Pisces,
No.
Taurus, all that stuff.
Because
and also,
guys-
Unless you're talking about constellations, that's fine.
yeah, cosmetology is also not science. That's the study of beauty,
Yep.
right? Anyway,
I don't care
so
how good Michelle
cosm-
Phan is, she is not a scientist.
So once again, we're talking about astronomy, not astrology, and we're going to talk about cosmology, not cosmetology.
Right.
Okay, but anyway, someone
So,
pick it up.
so the Big Bang Theory, just to kind of give you a overview of it, is according to the theory, approximately about 14 billion, that's billion with a B, years ago, everything in the universe was gathered together into one small, extremely tiny, teeny, tiny point called the singularity. And it's under extreme pressure, temperature, and density. Density because you're taking the whole universe and smushing it into this teeny tiny little speck. We're like talking smaller than like a dust particle. And then for some unknown reason, there was this tremendous explosion that basically caused everything in the universe to rapidly expand outward. And as that happened, you started to get actual creation of all the different types of matter and elements and everything came together. And then it kind of goes from there into forming stars and galaxies
So it has
and
a lot to do
protostars
with the
and so
transfer
forth.
of energy to matter.
Exactly.
Is a lot
Yep.
of this, and that's where you guys have probably heard of that E equals MC squared. Some of that relates to this. It has
Right.
to do with the
Here's a picture of it, though, where you see how that rectangle gets bigger. That means the universe is getting bigger.
Mhm.
Then as you go up the chart, that's actually signifying time. So over time, the universe is expanding.
expanding. It keeps going
Everything's-
out like an explosion or ripples. They keep going out from a point of
Yep.
origin.
And they keep getting, everything gets farther away from everybody else.
Yep.
Yep, and the reason why we move, I mean, that's powered partially by gravity, but also part of our velocity going around the sun is the velocity that we're still using from the original Big Bang.
Yep.
So let's get this to give us a little idea. The Earth is spinning, then the Earth is spinning and going around the sun. Okay, and all of the bodies in our solar system are going around there, and then our solar system is moving in the galaxy, and the galaxy is moving around in the universe. So everything is moving at all
times.
And it's still using that energy
And
from
it's
the
still
Big Bang
using
Theory.
that initial energy. That is how much energy was
It's a
released.
long time ago, too.
So my question is there any evidence for this?
Yes.
I would say yes because it is a theory and
Right.
it has to have evidence and a foundation.
Right. So
Take that, naysayers.
we have been able to figure out that the universe is constantly expanding.
Yes.
And then when we look at other galaxies, we could actually see that galaxies moving away from each other.
Yep.
And there's a few ways we could be able to tell this. The first is redshift. We'll do a little more demoing of this in
Yeah,
class.
we got more information on redshift in
But-
class, but try to get it down.
If you remember the Doppler effect, when an ambulance kind of passes by you and the pitch drops, okay, that means the waves are spread out, right? Now, if you do that with light, because stars emanate light, okay, if you do that with light, it spreads out the light waves. And if you remember all the types of visible light, so red or blah, 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 Roji
Yes.
Biv, okay, they all have specific wavelengths. And red
Right.
has the longest wavelength,
Yep,
and violet has the shortest wavelength.
yep.
Now here's the thing: when that light is coming at us at a constant frequency, it looks white. But when the object's moving away from us fast enough, the waves of the light actually spread out and appear to be slightly red, and that's
You
called
can see in that
redshifting.
picture where
Right.
the green arrow is showing that the light source is moving away from the eye of the person.
Yeah.
You can see that red wave
Yeah,
is spread out more.
So it makes it look like it's shifting towards the color. red.
Yeah, it makes it
Yeah.
look more red than white.
and on the flip side, stars that are moving towards us look blue because blue has higher frequency. The waves get smushed together.
Blue shift.
Blue
So
shifting,
more
yeah.
blue than light.
So, and if you look at most of the stars, and you can't just see this with the naked eye, you actually need instruments to be able
you
to
need spectrometers
detect the,
and things like this.
spectrometer. Yeah, you guys
Right.
have used spectrometers. But you could actually see that most of the stars are red, meaning most stars are moving away
Away
from
from us.
Now, the interesting thing about that, and we'll talk more about this later, is that the actual color of a star is not the same thing as what's being perceived through
Right.
redshift.
Yeah,
So
no.
when
It's
you
the
hear
light that's
yeah,
getting
when
to
you hear
us.
scientists and stuff talk about how that's a red star or a white star or a yellow
Yeah,
star, they're
that's
actually
independent of this.
Right, they're accounting for
Yeah.
the redshift.
Yeah.
we should mention.
Yeah,
Yeah.
It's the color itself.
So,
How about some cosmic background radiation?
Woo, I love me some of that.
First, let's talk a little bit, you guys, just to give a refresher. Radiation is basically when you have elements decaying or elements giving off particles. They're falling apart. They're not as stable as certain other isotopes in that. So what we're talking about here is showing some cosmic radiation for the universe. And one of the big things there, you can see a couple of scientists right there in the mid-60s started to measure microwave background radiation in the universe. And they found a couple of really interesting things. First off, they found radiation that they believe came from the Big Bang.
Very cool.
Which is pretty big, because if you're going to talk about explosion, there better be signs of the explosion other than I think it happened.
Right.
And that was one of the first big traces of that. And then just recently, just about a year ago in 2013, they actually used that to kind of revise the age of the universe, because I think before that they were leaning more about, 12.8 or 13?
Something like that. Yeah, it's
Yeah.
got older.
Yeah, it's a little older. It's a little older now. So we're getting better, because remember, guys, theories can be revised and added onto as evidence comes in, but you just can't change them willy-nilly.
True.
So we're revising this, but it doesn't really change the theory. It just adds more credence, more weight to what we were already believing in the theory.
Or
So-
slightly modified.
also,
yeah,
also,
modifying it.
also worth pointing out, there's groups of scientists that were still working on this theory even after it's established. So when you make a theory, it's
Yeah,
not like,
good
oh, we're done
point.
with that.
Yep.
We
Good
figured
point.
it out. You keep working on it, trying to refine it.
Get better
even-
and better.
even-
Feed on
take a
it,
look at
see if it
previous
holds
evidence.
up.
Yeah,
Sometimes
exactly.
trying to disprove it, we'll find new and better information.
Right,
Just trying to
which
beat
is
on something.
kind of what happened here.
Yep.
Yep.
Anyway, that tile gets cut off a little, but that's okay. They can figure
It
out
says
how
how
to.
do stars and planets form?
Yep. So now the way a star or planet forms is first everything starts off in what's called a nebula. Now nebula, and this is the famous. Is that the Horsehead Nebula or the? Eagle?
That's that one of the two. I don't remember.
Yeah.
That's,
Or is it
I
one of
think
the pillars of creation? I forgot which one I put up there. So anyway,
No, that's not Horsehead. That's
that's
got to
not
be Eagle.
Horsehead's
yeah, it's not Horsehead. But anyway, so a nebula is a big swirling cloud of dust and gas. Now, when I say big swirling cloud, I mean like a really, really ridiculously big cloud.
We're talking like
Way
galaxy
bigger than the
size.
solar system.
Yeah, like our planet.
So
would
not
look
like a cloud
speck
up there.
Of dust to
Okay.
it, like
Now, eventually, through different interactions, this dust forms a spherical cloud that rotates.
Yep.
And eventually, it condenses and develops a gravitational pull. And at that point, as energy accumulates, hydrogen gas that is in there gets fused into helium.
Yep.
Yep.
That's called fusion.
And
fusion.
poof,
That's a
star is
nuclear
born.
reaction.
Right.
There's your.
Yeah, so it
Your
releases
nuclear
energy.
reaction.
And it turns into a protostar and all that, but we'll talk about that in another video.
One of the really cool things about this is like they actually have long time images of nebula where they can actually see stars being born and popping out the tops of
Yeah.
them, which is
Yeah.
kind of cool.
So-
Yeah,
as
there's
you
like a
fuse-
NASA app that you could actually look
Yep.
at. They actually find them every few months or
Oh,
so.
okay.
Find
Look at that.
nebulas where you can see stars forming.
It's really
Of course,
cool.
those images are millions of years old.
Right.
So
but
what
to
you
us,
guys
they're
are
new.
saying is, as you start to fuse the dust and the gases and the chemicals in those clouds, and make them more dense, they start to get a gravitational field of their own, and they rotate, and you start to actually form high energy bodies like
Yeah.
stars and that. So it's a condensing of that energy in that
Yeah.
together.
Yep.
So again, it's matter and energy.
And the reason we put this in here is because when the Big Bang happened, you didn't just have stars all of a sudden.
Yeah.
You had a bunch of nebulas that
Yeah. Right.
eventually formed into stars.
And that
So,
energy kept them swirling and moving and colliding until we got these reactions.
so this cloud, this round cloud, rotates. It becomes a large disk. Okay, and eventually
Frisbee.
rocks, as things fuse, they become denser and denser
Yep.
elements.
Right.
Those rocks will attach to each other, and they'll form planets, so on. They go around a middle central point, which is the star. So this is basically how solar systems form. Stars plus
in a very
planets.
condensed.
Yeah.
And it's like a snowball
And
effect.
we
too.
we
Yeah, let me
recapped a
really
very,
run
very
over it.
complicated process.
But it's like a
Yeah.
snowball effect. As things start to group together, more stuff in its proximity starts to group together
Right,
because
right.
it gains gravity, which makes more gravity, more and
Right.
more and more, and a spherical shape is just
And
what's
remember,
going to
people
result from
devote
spin.
like their entire lives to studying this stuff, so we just condensed what somebody probably spends their entire
Yes.
life describing into a 30-second thing. But hey,
This
you
is
get the idea.
thousands and thousands of years of human knowledge condensed
Right.
into one slide.
Yep.
So if we're going to talk about the birth of the universe, we should probably talk about how it's going to die, because everything dies eventually, sorry. And there's a couple different theories as to how that's going to happen. One of them is the Big Crunch theory, which is kind of interesting in the fact that as our galaxies are spreading farther and farther apart due to the Big Bang, eventually they're going to get old and stop having enough energy and stop producing
Yep.
those things, in which case then enough matter will be created which will cause the gravity to start to cause everything to slowly retract in on itself. And the idea is that eventually everything will kind of crunch itself back into that point of singularity again and go squish.
So it's
Yep.
like spring, boom.
Right.
Yeah.
And maybe it's happened
Here's
lots
a
of times.
here's a picture of that.
Right.
Um,
Notice rendition of it.
Yeah,
Yeah.
the actual thing
yeah.
happening.
Yeah, that's not a real thing. Yeah.
That would be weird.
So anyway, the last one.
The last one is the Big Chill. And basically, Big Chill has to do with matter in the universe and that. So it says if there's not enough matter in the universe to provide gravity necessary to stop the expansion, then it's kind of the opposite of the crunch. The crunch said, hey, it's going to all come back in. This says it's just going to keep going and going and going and going, and energy is going to keep dissipating. We're losing kinetic energy and all that, and pretty soon everything's just going to stop moving.
Because
When
there's not
stuff
going to be
stops
enough
moving-
energy to keep temperatures
Right.
up. To,
Exactly.
And
And
it'll
when stuff
get
stops
very-
moving, temperatures drop. You don't have motion anymore. When
Right.
you don't have motion, you don't have
we'll
temperatures that are.
It'll just be very cold and dark. That's
Yeah.
kind of what they're saying. And
Yeah, it
basically
won't.
everything's
It's
kinda-
basically it won't support life anymore. Now that doesn't mean that there won't be
Right.
inorganic bodies and things like that that are still existing, planets and stuff like that. But they're just going to spread and just drift out, and it's just a kind of whimper and it's gone.
And the sad thing is this is the theory that has the most, I don't know,
Yeah.
backing or evidence, I would say, to it right now. This is the one that they think is the most likely option to happen.
Yeah. Although this one, there is quite a bit of debate on how the universe is going.
Well, yes.
We're not when we use the word theory for these. It's not nearly as supported as
The Big Bang.
the big theory. In fact, you see the theories are conflicting with each other, right?
Yeah.
Which happens sometimes.
Yeah, well,
But-
because we don't have enough information yet, but
Right.
we're working on that.
True.
So.
This is also the theory that got a movie named after it.
Do
anyway.
not watch The Big Chill.
Yeah, it's a sad movie, but anyway,
I don't think I've seen that movie.
it's sad.
It's
but
a
anyway,
horrible old people movie. It's terrible.
Oh, okay.
it's not that bad. But anyway, all right, that's it. Make sure you do your checkpoint and have a good
Do
day.
your checkpoint, guys.
Bye.